Okay, so this lesson today we're going to talk about two different things. The first is residuals and what those mean. And then the second thing we'll discuss today is reading computer output. So there's two main goals for today. So suppose that we have a data set that has 3 ordered pairs. And then we have calculated a line of best fit. So you could have something as small as 3 data points and calculate a line of best fit from that. So the best LSRL that goes through that is somewhere that is a halfway point that's going to minimize all of the deviations as small as possible. And so that's what an LSRL does. It tries to minimize and go through as many points as possible and minimize the space that is between that point and the LSRL. Nope, that's not right. There we go. So now we want to find the vertical distance from each point in the line. So what I would do is I would plug in each x value into the LSRL, and that's going to get me a predicted point. So, for instance, if I wanted to find the vertical distance from 0, 0, so here is my point. We call this the actual observation, or we also say the observed. So that is when I took a sample, that is actually what I got. However, when I plug in 0 for x, so if I'm plugging in to my x value, I'm going to get the point 0, 4. This would be my predicted value. And so the distance between those is called a residual. It's the deviation or the distance between my actual and my predicted, like how far I am off of that. So I have a -4 deviation. That means that my actual is 4 points below what was predicted. So we predicted that I would be at 4, but I'm actually at 0. So I'm 4 points below. If I did that, the same thing for x equals 3, you end up getting 5.5. So I'm 4.5 points above. And then if you did the same thing for 6, you would get -5. So notice, you might want to make a note in your notes, anything that is below your LSRL is going to be a negative residual or a negative deviation. Anything that is above is going to be a positive. So negative would mean below, and then positive would mean above. If I have a negative deviation, do you think that that means that I have over or underestimated? So if my actual is 0, 0, and I predicted to be at 0, 4, then did I over-predict or did I under-predict? Over. So if I have a negative deviation, that means that I overestimated, which is sometimes people mistake this or they get it backwards. Because if you have a negative deviation, that means the actual is below, so I overestimated. So if I have a bunch of negative residuals, that means that I overestimated. Maybe I predict what everyone's going to make on the test, but then everybody is down here. That means that I had too high of expectations for you, and I overestimated what I thought you'd make on the test. Which never happens. However, if I have low expectations for you guys and everybody is up here, then that means that I underestimated you.
How could you do that?
How could I do that? That means I underestimated you. So if you have a lot of positive residuals, it means I underestimated. Negative residuals, that means that you overestimated. There will be a lot of questions about that sort of thing. Maybe looking at a scatter plot and saying, did this person over or underestimate? So based on where your data points lie, if they're underneath the line, then you would say that they overestimated. If they're above the line, then they underestimated. So we're not ever going to have to know this formula, but I do want you to kind of understand how we end up getting the LSRL. So if I find the sum of these deviations, so if I found just the sum and I didn't square them, what do you think that they would add up to? If I just added all the deviations together?
0.
they would end up adding to 0. And this is a faulty example because there's only 3. But in actuality, like if you were to really do a scatter plot, your LSRL, if you added the deviations, they would add to 0. So, yes, everybody's here. So, I thought that I did that today.
Is Elena in class anymore?
She's not in bio. Didn't someone say my group?
I don't know.
I think you're wrong.
I don't know. Anyways, everybody's here. So if I added up all the deviations, they would add to 0. I know that this example is not it, but not accurate, but it would add to 0. So you have to square them first. If you found the line of best fit, so the LSRL, this is the actual one. I don't know why they show that example first. But now, okay, this is the accurate LSRL. I think in the first example, they just say draw a line that you would think goes in between. But this would be the correct LSRL. Will it always be 0? Yes. Yes. So if I had you guys put this in the calculator, this would be the LSRL that you would get. Which kind of looks low, but since you have 2 points below, it's going to draw towards the points that you have the most of. So if I have 2 points at the bottom, it's going to be closer or nearer to those than it is to the top one. So that's going to have to compensate. So your deviations always add up to 0. If I square them, add them together, that number is 54. So this number represents right here. So if I squared these and then added them together like we did for variance, remember that. If I squared them, added together, this 54 represents the smallest number possible of squaring and adding the squaring and adding the deviations. So this is the smallest number possible. That is how we end up getting our LSRL, because it minimizes this number. So on the last example, when you did that, I think we ended up getting like 62 or something. So this line minimizes this number, which is the sum of the squares of your deviations. It's the smallest number possible. Will I ever make you calculate that? No. But you do need to understand that an LSRL minimizes the sums of the squares of your deviations.
Yes.
That's what the concept is. Yes. Interpretation of slope, we talked about that last class, but just a refresher. Remember that whenever you're talking about interpreting slope, it's for every 1 unit increase. You do need to put the unit into context. So don't say the word unit. Say whatever your x-axis is measured in. Is it measured in years? Is it measured in points on a test? Is it measured in, what's another example? Number of dogs that you own. I think that might have been what you had, or your scale of rating of dogs. So your unit it's in green because it means that I want you to write a word there. I want you to write what your x-axis is measured in. So for every 1 point increase on a test, there is an approximate increase of 0.5, half an hour studied on the test or something like that. So you're inputting words here, 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 and you're picking either increase or decrease based on the slope, positive or negative slope. So you should never have the word unit, x, b, or y in your final answer. You should substitute words that are relative to whatever problem you're talking about. So that's what I mean by script. So when I tell you to memorize a script, I want you to memorize this sentence, but I want you to be able to translate it into any type of scenario that I give you. Okay? Okay, so what I want us to do next is I want you to put this data into your calculator. So put your x's in list 1, your y's in list 2. So put your x's in list 1, your y's in list 2. Okay, now I want us to calculate the LSRL. So does everyone remember how to do that? In my calculator, I go to stat, Calc. And then what number? 8. 8. Not 4. 8. So my y hat equals, someone tell me what it should be. What is my y-intercept?
Negative 269.75.
Plus, what's my slope?
37.25.
X. Make sure that you put your hat. What is my correlation coefficient? 0.998. Okay, so I have my LSRL and then I have my correlation coefficient. We're going to work on interpreting those, okay? So if I wanted to interpret the slope in the context of the problem, if you go to page 99, so maybe you hold your page and then go to 99. My x-axis is number of days after injection of cancer cells in mice assigned to plain water. I know. I know, they're doing cruel things to mice.
It's like the circumference of baby's head.
So I think, if I were to read this whole thing right here, basically what it's saying is they're measuring the tumor volume, like whether it's growing or not, based on what type of water that the mice will drink. So there's 3 groups. We have just plain water, and then we have water supplemented with 0.1% pomegranate and then 0.2% pomegranate. So they want to see, and when we get into experiments later on, this will be more relevant, but right now, they want to see if pomegranate extract has any effect on the growth of tumors or the size of tumors, either in a positive or negative direction. So my X is the number of days, like I'm counting 1 day, 2 day, 3 day, 4 day, how many days after the injection, and then I'm also counting the tumor volume. So as you can see with a positive correlation, the more days that are after, the size in the tumor is growing. And this right here is just for plain water. So this has no pomegranate at all. Okay, so they're just injecting plain water into the mice. So if I were to interpret this slope, my slope is which number? B, which is 37.25. So if you look at the script on page 99, I would say what? So for every increase of 1 unit, what is my units for X?
37.22.
No. For X. Like what am I measuring X in? Days. So for every day, because when this is changing, so for every day that after injection, so for every increase in 1 day after injection, the Y, so the average tumor volume is increasing by how much? 37.25 millimeters cubed. Good. Millimeters cubed because it's volume.
How is it started as a negative?
How is it what?
How is it started out as a negative?
We're going to talk about that. Okay. So the slope, every increase in each day, the volume of the tumor increases by 37.25 millimeters cubed. Okay, that would be slope. Remember that an interpretation is stating the definition in context, so you have to talk about what the original problem is talking about. For R, that's when you do LSD, so there is a strong positive linear relationship between X and Y. So linear is, you just keep that word. Strength, it is strong because why?
Because it's really close to 1.
Yes, because it's really, really close to 1, so it's strong. What are the boundaries again? What makes something weak?
0
Less
to
than
0.5.
0.5 or negative 0.5 to 0. What makes something moderate?
0.5
In the middle.
0.5 to 0.8. What makes something strong?
0.3 to
0.8 to 1.
One.
Yes.
I was close.
So we have 0 to 0.5 is weak. 0.5 to 0.8 is moderate. 0.8 to 1 is strong in the positive or negative direction. And then it's positive because the slope is positive and my R value is positive. So both of those make the direction positive and then linear. And then lastly, the y-intercept. So y-intercept is negative 269.75, which means that the volume of the tumor is negative 269 millimeters. cubed.
Impossible.
Is that possible to have a negative volume?
Yes.
No, it's not. So, does this intercept have meaning in context? No, it does not. It does not, because it doesn't make sense to have a negative volume. So if this were a question that I would ask you on a test, you would say no. Okay, so I would say no. It does not make sense because there cannot be a negative volume. So having a negative volume at 0 days does not make sense. So it says, the next problem says, predict the average volume of the tumor for 20 days after injection. So if I want to predict for 20 days, what do I need to do? I need to put 20 in for X because I'm predicting the volume, so I'm predicting Y when it gives me 20 days, which is X. So Y hat equals negative 269.75 plus 37.25 times 20. And that gets me some number. So you should get that Y hat equals 475.25 millimeters cubed. I am looking for the units as well. And make sure that you put Y hat equals, because it is a predicted Y. Okay? Now it says predict the average volume of the tumor for 5 days after injection. So I would do the same thing. I would just plug in 5. And I do get a negative number, so that really doesn't seem accurate, does it? Because you have a negative number. So will this LSRL be accurate for every single X value?
No.
No, it will not. Because can volume be negative? No. So we call this danger of extrapolation. So I want you to circle that example, and I want you to put extrapolation. And I'm gonna talk about what extrapolation means, okay? So your LSRL should not be used to make predictions for any X value outside of your own range. So what that means is, what is my smallest X value on this in this data set? 11. And what is my largest? 27. So I can only predict X values from 11 to 27. I can't predict 28, I can't predict 10 because my LSRL becomes no longer accurate or relevant. It is only within those two bounds. So I cannot predict anything outside of 11 or 27. And if I do, if I go past 27 or before 11, it is possible, and you may have a test question that asks you to do that. So don't say, I can't do it because of extrapolation. I want you to still answer the problem, but say, okay, but I have a danger of extrapolation. So always answer the problem. If I said predict at 30, or even if I said predict at 5, I'm looking for this answer right here. I'm going to check that, and it's either going to be right or wrong. But then I want you to say danger of extrapolation. Danger of extrap. So they may ask you to predict outside of it. I still want you to give me an answer, just like I want you to interpret the y-intercept. But I do want you to say that you could have extrapolation. So it may not be accurate. But people extrapolate sometimes, and you just kind of have to accept it. So it is unknown whether the pattern observed in the scatter plot continues outside of the range of X value. So it could happen that maybe after 27 days, the mice will do something weird and it'll change completely. I don't know. That is a weird example, but you don't know what happens outside of the bounds of those X values is what it's trying to say. Okay, the next type of example, this is different because a lot of times I ask you to predict Y when you're given an X value. But if I ask you to predict X given a Y value, you do something completely different. You do not plug in for X, or you do not plug in for Y hat. So I want you to write in big, bold words, never plug in for Y hat. Just don't do it. Don't ever plug into something that has a hat on it. You
Because
can't.
Not an absolute like number.
So what does that hat mean?
What does that hat mean? That means predicted Y. Okay, so this question is saying, suppose we want to know how many days after injection. So I want to know my X value and I'm given a Y value. So Y equals 500. So what we are going to do, if the question asks you to do that, we are going to switch. So I want you to go to Stat, Calc, 8, and I want you to make your X list L2, and I want you to make your Y list L1. So we are basically switching our X's and our Y's.
Is there an easier way to do that?
No.
No. I don't want you to go into Stat Edit. I want you to go to Stat Calc 8, and I want you to just switch L2 and L1. Yeah. So I'm making my X list, my second one, my Y's, and I'm making my Y list, my X's. So I'm just switching them. But don't go into your original data and flip-flop. Does that make sense? Okay. So once you do that, it's going to give you a new LSRL. And instead of being Y hat equals, I am now going to have an X hat equals. So X hat equals A plus BY. So my X hat, what is my Y intercept for this?
It'd be the 7.277.
Plus, what is my slope?
The slope would be 0.026. Wait,
0.026?
0.027.
027. Okay, we gotta learn how to round. 0.027 Y. It is on the video, yes. So now I'm gonna plug in for my Y. I'm gonna plug in 500. So X hat equals 7.277 plus 0.027 times 500. And that is gonna get me a predicted X value, okay? So when you have original data and it asks you to predict X instead of predict Y, you must switch your two lists. So you must switch. Please switch the lists.
When you're looking for X.
Do not plug into Y hat, because what I see so many times on a test, because you know I'm going to give this to you on a test. What I see so many times is that people plug into Y hat and they put, nope, they don't put 500 there. They put 500 right here. And then they add the 269 and they divide by the 37.25. That is not right. No. You're going to get numbers that are kind of close. I'm not going to lie. They're going to be pretty similar.
Okay.
But I'm going to put both answers of them on the multiple choice and I'm going to ask you to pick the right one.
It's 20.66. We got 20.7.
Yeah, it's very close.
This is just like
I know.
right time. I'm not
So you get 20.7 for your answer?
Yeah. Well, 20.656 and 20.664.
Yeah, something like that. So the difference is, you know, when you have that equation that's on your formula chart and you solve for slope by getting R equals S, this one is the one that's on your formula chart. So slope equals R SY over SX. I think that's the one that's on your formula chart. This one would be when you have a Y hat, but whenever you have an X hat or you're predicting X, it changes to this. So that is why we must switch them. The slopes are different. So the regression line of Y and X should not be used to predict X. That's why we say do not plug in to Y hat, because it is not the line that minimizes the sum of the squares in the X direction. So that's why we must switch them. And I would only ask you to do this if you had original data, okay? If you only had original data that you put in your calculator. If I want to find the mean values, X bar, and the mean values of Y's, the Y bar, how could I do that? How could I find the averages of those?
Add them up.
Plug it in the calculator.
Add them up, divide by 5. What if I had 75 data
Underrated.
points?
Hard work pays off.
Then you don't do it.
Then you do, how would I do it if I had 87 data points?
Add them up and divide by 87.
Put them in a list. So if this is in list 1 and this is in list 2, I do stat, calc, enter. So 1 bar stats.
87. So
Or listen, or since we have the same number of points for X and Y, if you do stat calc 2 var stats, it will now work for you. 2 var stats. So let's try that really quickly. Stat calc 2 var stats. I think it's option number 2. And then use list 1 and list 2.
So back to the first way.
Uh-huh.
Back to list 1.
So 19 and 38.
So my X bar is 19.
Yes, that's true.
My Y bar is what? 438. Is that what everybody else got?
Exactly.
438.
She just doesn't trust me.
Don't trust you.
There's no trust issue. She just doesn't trust.
So if you plot that point on the scatter plot, it's actually in the very center. Do you see that red dot right here? I'm going to make it a little bit bigger. It's right. This is it right here. So this is 19, 438. It is on my LSRL. It is always in the center. It is always the middle of your data. And it always fits on your LSRL. So X bar, Y bar is always on your LSRL. So I do want you to make a note of that. The ordered pair X bar, Y bar is always on your LSRL. Always, always, always. If it's not, then you did something wrong. Yes. Okay, so page 105. Oh no. Oh no. Go to page 105. I think that this kind of just goes along with it, but it's a linear regression activity. I want you to put your X's in L1 and your Y's in L2. Then it says sketch a scatter plot, find the least squares regression equation and the correlation coefficient. Okay, so scatter plot should look like what you see here. You should label your axes. So make this X, this is Y. To get the Y hat equals, so this is my LSRL. Remember, you just do stat calc 8. So I hit stat calc 8. This is my A and this is my B. So it is Y hat equals A plus BX. So I'm just putting those numbers in. There's no calculating involved. Then my R is my correlation coefficient. So my CC, my correlation coefficient. So just based off of that, looking at that number, if I were to describe the correlation coefficient, what would I say? Strong positive linear because of the 0.916. Strong positive linear. Good. So if you go back to stat edit for number 2, I'm going to add 5 into my list 1, and I'm going to add 8 into my list 2. I want you to calculate a new LSRL.
I didn't know.
Oh wait.
What question are you doing?
Are we back to yours?
Add 0.58.
So add the 0.58.
And then you plug in the X.
So add the 0.58. So add 5 to your list 1, 8 to your list 2. What happened? So if I calculate a new LSRL,
You get 2 dots.
you should get Y hat equals negative 1.15 plus 1.17. And then my R decreases significantly, and it becomes 0.667.
That was really close.
Was. So what do you notice about this dot in relationship to my LSRL? Like, is it close?
No, it's the
Is it further away? It is the furthest away.
That's not good.
Far away. So when I add a dot or I add a point that is far away from my LSRL, it is not helping my situation. It is hurting. So it hurts my R value. Makes it sad. It went down. So it weakened my data. Because I'm trying to prove a point here that I can predict Y when I'm given an X. And this point kind of screwed everything up. It weakened my data.
Dangerous extrapolation right here.
It's not an extrapolation because it's within my X values.
I mean danger of, but not dangerous extrapolation.
No, it's not an extrapolation because I could predict values between 4 and 8. Because this is my lowest point, this is my greatest point. 5 is within that range.
Why is it saying to do the correlation coefficient? Yeah, we're recording R.
Okay, so erase the 5, 8, and then add 12, 12. So add the point 12, 12 to your list 1 and 2. Calculate a new LSRL. And then calculate a new LSRL and a new R value. Okay, so when you calculate a new LSRL, you should get negative 2.24 plus 1.225x. And now my R value, or my correlation coefficient, is 0.959. So here's my point. What happened? Is it on my LSRL? Is it close? Yes. So it is on the LSRL, and it's further out. So what happened? I now increased my range. So I strengthened. It was good.
Should we draw a line on these? Is there a line that pops up? Do we need to draw?
No, you don't have to.
Okay, sweet.
So if I added, I did two things. I added to my LSRL and I widened my X range because now I could predict anything from 4 to 12, whereas before I could only predict from 4 to 8. So I have strengthened it, I've increased my range so that I won't extrapolate, and it's made life a lot better. So when you have a data point on your line, your LSRL, then that can strengthen it. So it can increase my correlation coefficient. It increases it. So if I add 12, 0, which is down here, it's extremely weakened it. Look at that. It is now negative. It threw off my whole slope. Who is this person that threw everything off?
Probably me.
Probably you.
100% me.
Yeah.
It's an outlier.
Is it?
I'm gonna send this video to her. She's gonna go home and like edit this clip out.
So it weakened it. It is an outlier. It is an outlier.
Yes.
It weakened. It actually changed my slope because it is completely off the LSRL.
Hey, that's me right there. We can do this class average. That's fine.
So it was a fun act. It was like Statland, kind of. So the correlation coefficient and the LSRL are both measures that are affected by extreme values. Remember in the last chapter, if something is not affected by extreme values, it was called what? Starts with an R. It was called resistant. But LSRL and correlation coefficient, they are not resistant. They are affected by extreme values. So they are not resistant. So the last script that we are going to talk about that you'll need to know before the quiz on Thursday is assessing the fit of a line of best fit. So you will get a question that says, is the linear model appropriate? Yes or no. There is a way to mathematically tell whether it is appropriate or not, and that's going to be involving the residuals. So we always automatically say that it is strong, positive, linear. We use that word linear, but we really can't make that assumption without checking it first to see if it is linear. Or if it's non-linear, we'll learn how to fix that in the next lesson. So we're going to test to see whether it's linear or not. So once your LSRL is obtained, the next step is to examine how effectively the line summarizes the relationship between X and Y. So important questions: is the line an appropriate way, which we're going to learn what appropriate is or is not? Are there any unusual aspects? And if we decide to use the line, then how accurate are the predictions? So those are questions that we ask ourselves when we're looking at a scatter plot. So what I want you to do, I don't think you have this data in your calculator, so I want you to add this to list 1 and list 2. I know. So if you put this data into list 1 and list 2, I want you to hit Stat Calc 8. When you do that, you should get, for your LSRL, y hat equals negative 7.69 plus 3.234x. Is that what everyone got? Yes. So another way to represent, like if if a question on a test does not give you all of the original data, it will give you this right here, which we call computer output. So we're going to do some more notes on that in a minute, but I do want you to see, so you don't have to write anything down yet, but I do want you to see that this first number is my y-intercept, and then the second number is my slope, but we're going to go over that in more detail in a minute, okay? So when you get your LSRL, this is what you should get. So if you were to make a scatter plot, which I'm not going to make you do just yet, but this is what your scatter plot would look like. You do have a positive correlation, and then this is your LSRL graphed. So just looking at that data, I would think that it looks linear. It looks like it's a good predictor, but I am not 100% positive yet, so I do need to check that. The vertical deviation between the point and the LSRL is called a residual. Stop talking. It's called a residual. So that is the deviations that we calculated. They were called, we didn't have a name for them, but now we call them residuals. So that is the vertical deviation. Remember that if you are above your LSRL, it's a positive residual. And if you are below, then you have a negative residual. If you added all of the residuals together, you would end up getting 0. Yes. If I wanted to, so if the point is below, it's negative. The formula for residual is your actual minus predicted. There are 2 ways you can remember this. So it is actual, it's hard to read that. Use a different color. So actual minus predicted. And one way to remember that is AP. So you're in AP statistics. Or you could also use observed minus predicted. And we came up with this my first year, that OP stands for old people. So residual is old people. Residual is AP statistics. You take your actual or your observed minus the predicted one. So Y minus Y hat. You do have to have this memorized. So you do have to have this memorized. You're going to highlight list 3 and hit enter to where there is a little blinky square. And we're going to type in our LSRL using these X values. So if I were to create some sort of like Excel equation, it would look like my LSRL, which what did we say our LSRL was from the, so negative 7.69, then what?
Plus 3.234.
3.234, and then instead of X, I'm going to put L1. And because L1 are all of my X values. So it's like you're inputting an equation. You highlight L3, you hit enter, there's a blinky square. I want you to type in this into your menu. It's like creating an Excel equation. And then it's going to output all of your predicted Y values. These are all of my predicted Ys. Okay? So these are all of my predicted Y values. So when you hit enter, you should get these values. They should match. Then I want you to go to list 4. And now we're going to subtract to find the residuals. So for my equation of list 4, what do you think that I would need to type in? If I am doing Y minus Y hat, which list is my Y? The second one, so I would put it L2 minus, and my Y hats are L3. So L2 minus L3 is going to give me all of my residuals. Here are my residuals, right here.
So you subtracted L2 from L3.
0.
So if I were to add up all of my residuals, then they would equal 0. Good. What does this remind you of? Remember when we did the variance activity? If you add up all of the standard deviation, or if you add up all of the deviations, then that would add up to 0 as well. Okay, so we're going to take those residuals and we're actually going to create a graph out of that. And when we make that graph, we're going to be able to tell whether the linear model is appropriate or not. So a residual plot is a scatter plot of the x versus the residual pairs. So when you are drawing a residual graph, it's going to look like this. It's going to make like a sideways T, where whatever your x value or variable is going to go on the x-axis, and then your y is going to be residuals. So you'll put residual. You're going to have some that are above the line, so this is always 0. You're always going to have some that are above and some that are below, okay, when you're drawing these. And our calculator will do this for us. So residuals can also be graphed against the predicted y values as well. So I just showed you the picture of x versus residual. You could also do y hat versus residual. I think it's easier to do x in residual because the y hat is harder to calculate, but both graphs will look exactly the same. So whether you use y hat or x, both pictures are going to look the same. Now, I always use x because it's just a lot easier to do that. So the purpose is to determine if a linear model is the best way to describe the relationship between x and y. If you don't have a pattern, so we are wanting to have no pattern. We want it to look like a bunch of stars in the sky. So we want our residual to be scattered with no pattern. Then we say the linear model is appropriate. If there is a pattern, so if a pattern exists, then linear model is not appropriate. So if there is a pattern, like it makes a straight line or it makes a curve or it makes a smiley face, then we would say that it's not appropriate. Like, we should not use an LSRL to predict y values. That's what it means by appropriate and not appropriate. So if something is appropriate, then our LSRL is good. Like, we should use the LSRL to predict. If it's not appropriate, so if I have a pattern in my residuals, then the LSRL is no good. It doesn't help me, okay? So we're going to learn how to make a residual. This graph right here, here's an example of one. Would I say that there is a pattern, yes or no? No. So my script would say the residual shows no pattern, so it indicates that a linear model is appropriate. Here's an example of where I do see a pattern. So I would say that the residual shows a curved pattern, or it shows a pattern, so the linear model is not appropriate. Now, I know you guys so well that I know you're going to stress and you're going to look at a residual and you're going to say, I think that there could maybe be a pattern. I could probably figure out some way to connect these dots and it looks like there's a pattern. Because I know how your brain works and you're like, I bet there's a pattern. I'm going to tell you right now, they are going to make it very obvious. There has to be an obvious pattern. Don't try to connect the dots. This is clearly scattered. And this is clearly patterned. Yes. So it is going to be obvious, I promise you. Don't try to like pull things out and be like, I think that there's a pattern because I can do this. Yeah. Yeah. So this is clearly scattered. Okay? So don't overthink it. Do not overthink it, okay? Because I know how you guys are. So when I am creating a residual, listen to this. Everyone look at me because this is important. When I am creating a residual graph, you do not have to go through these entire steps. So you don't have to do this. You don't have to do the L3 and the L4. When you are making a residual graph, you do not have to do this. This was to show you how to get residuals. So that was the only purpose of doing the L3 and the L4. Your calculator will store residuals for you. When you calculate your LSRL, it automatically stores residuals in its memory for you to use at any time. Okay? So you do not have to do this every time. If I am making a residual graph, So to make a residual graph, I want you to go to your, so make sure first, when you're creating a residual, make sure first that you are calculating your LSRL first. So step 1 is calculate LSRL. Because if you don't, every time you calculate an LSRL, it is refreshing the residuals within your calculator. It refreshes them. So if you typed in your data and you tried to make a residual graph, it would not work. You have to calculate the LSRL first, then the calculator calculates the residuals for you at the same time. So make sure you have done that first. Next step, so once you've calculated your LSRL, I want you to go to your, I'm going to try and minimize this. Nope. So I want you to go to your calculator, which I'm going to bring over here in a second. So once you have calculated your LSRL, I want you to go to second, y equals, hit enter. My X list stays as L1 because those are my X's. Then on my Y list,
So we have to change this every time I want to go, which means
so if you go to your L2, if you go to second stat, so hit the second button and the stat, it is option number 7, which is resid. Yes.
Mine is CNTRV.
Okay, then go to 8. It might be 8. Some versions are different, but make sure that you choose the one that says resid. So your X list should be L1, your Y list should be resid. Then you are going to hit zoom 9. Here is my residual. So the y-axis is going to say resid. The x-axis is going to say x, whatever the x is in your equation. Distance from, I don't know, whatever it is. Whoa. Distance from debris. That's going to be your x-axis. So it needs to be in context. So you're not going to just put x. Then you're going to draw your dots. There does not need to be any numbers on it as long as your points match with what the actual residual should look like. So I know a lot of you would say that there is some sort of pattern in this.
No, there is. It looks like the United States.
You would try to do this and say there's a pattern. There's not. There's no obvious. I just know how you work. I know that y'all do something like that.
that's kind of stereotypical, but
I know. We do that in here. So the script would say, since the residual plot displays no pattern, a linear model is appropriate for describing the relationship between the x and the y, and that must be in context. So if I did this against my y hat, which I think you guys have in your L3, so if you wanted to go back to second y equals and then change your x list to be L3, which was your y hats, you would end up getting the same thing. I'm not going to make you do that, but I do want you to know, so for a quiz or test, that if you do a residual of x versus residuals or y hat versus residuals, you end up getting the same thing. They will show the same picture. Okay? So they are the same. That's what you want to know from that. So residual plots can either be plotted against x values or predicted y's. Okay, the last thing we're going to talk about today is coefficient of determination. That is my r squared. It gives the proportion of variation in y that can be attributed to the approximate linear relationship between x and y. So I want to explain this as best as I possibly can because right now it seems like it doesn't really make sense and it's like, what are those words saying? So if you want to memorize this, then you are more than welcome to just memorize and go along and live your life, and that is fine. If you want to understand why, then listen to what I'm about to say. So you always have r squared. It's always going to be a percent. You're going to put it in a percentage whenever you're doing your scripts. It needs to be in a percentage. And if it gives it to you in a decimal, then change it to a percentage. So let's say that I calculate data, and I do my x-axis is hours studied, and my y-axis is test grade. And Courtney, you did that. Do you remember what your R-squared value was?
91.5.
91.5. Let me look at it. I'm looking at it right now. Yeah, 0.915. So Courtney got 0.915, so that would be 91.5%. So what that means, based on her 10 data points, is that 91.5% of the reason why people got the test grade that they got is because of how much time they studied. Okay? So whether that is completely accurate on her data or not is not my problem, but it is what her data is saying, okay? So listen to me again when I say this. 91.5% of the variation in Y. So of the results in test scores can be attributed to the linear relationship between X and Y. So the relationship between studying, so hours of studying, and test scores. And the other 8.5% is for other things. So other attributes, like maybe how much time you slept, so the amount of sleep you got, how much you did your homework. So that other 8.5% are other factors, but 91.5% of it is because of the linear relationship between X and Y. So a lot of times test questions will say the proportion of, so 91% of the test scores can be attributed to the hours studying. But you have to say the linear relationship between X and Y. So the relationship between studying and test scores, 91.5% of it is why you made the test score that you made. Does that kind of make sense? Yes.
Is that like the kind of difference between like the causation and correlation?
Yes.
So stronger R squared.
Stronger R value is that there's a higher correlation, means that there's more of an association between those two variables.
And R squared is that more causation, or is that still?
Causation is not until we get to experiments. So this doesn't have anything to do with causation just yet.
Correlation is not.
So our formal script that I want you to memorize is, so approximately R squared percent, this is in a percent, of the variation in Y, so the variation in test score can be explained by the LSRL of X and Y, or X on Y. So of hours studying and on test scores. So you're just replacing. So for the purpose of the scripts, I want you to write this verbatim because that's what's going to get you full credit on the AP exam. But as far as like understanding what R squared is the explanation that I gave you. Okay? But it has to be word for word on a test. It really does. If you try to deviate from that verbiage, that's why I give you the scripts. If you deviate from that, there's a potential chance that you could get it wrong. So if you just want to understand it and write it in your own words, you may not be guaranteed to get full credit. So that is why I say memorize the scripts. Memorize.
This whole chapter, memorize the scripts.
Here is the summary of interpretations. It is on... Oh, now I want to go back. This is on page 99 on your notebook. So memorize 99.